the slope of the tangent is given by dy by dx. The slope of the normal is given by minus 1 over dy by dx. So we need to find out the point of contact, at which point the tangent meets the curve. So let us take here y is equal to root of 4x minus 3 minus 1. See, x minus 3 whole square is a positive quantity, but here we are getting it as minus 1 by 2. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we are moving with another important application of derivative, that is the tangents and normal. How to find out the slope of a tangent or normal, or how to find out the point of intersection to the curve and tangent and normals, or how to find out the equations of tangent and normal whenever its slope is known with the help of its derivative. So let's see about tangents and normal. So here is a curve which I have taken. So a tangent is a straight line which meets the curve only at one single point. Any perpendicular line to the tangent is nothing but the normal. So here generally the curve is taken in the form of y is equal to f of x. So any function of a curve is expressed in the terms of y is equal to f of x. So we already studied in the Rolle's theorem and mean value theorem. So if you have any curve, you can draw any number of tangents at the particular line, and when you draw a tangent towards that point, so that point indicates the derivative of f of x at that point. So here also the derivative at that point is given by dy by dx, which is nothing but the slope of the point at the given point x naught comma y naught. So here is a point which can be taken in the form of x naught comma y naught. So a straight line passing through this, which is a curve to the tangent, is defined by dy by dx of the curve at x naught comma y naught, or we can also write it in the form of f dash of x naught. So dy by dx is nothing but the slope of the tangent. Now, a normal is the perpendicular line. So any line which is perpendicular to the tangent is nothing but normal. Then how do the slope of the normal is given by? The slope of the normal is given by minus 1 divided by f dash of x naught. That means, so minus 1 divided by f dash of x naught means, see what is f dash of x naught? It is nothing but dy by dx. So this can be written as minus 1 dy by dx, or we can write it as minus dx by dy, which is one and the same. So minus 1 divided by dy dx is nothing but minus dx divided by dy. Therefore, what we can call is the slope of the tangent is given by dy by dx. The slope of the normal is given by minus 1 over dy by dx. Once you find out dy by dx, just take the reciprocal of dy by dx, you will get the slope of the normal, but you have to take the negative slope of the normal. So why here negative is defined here? We know that when two lines are perpendicular to each other, the product of their slope will be equal to minus 1. So if the slope of the tangent is m1, then the slope of the normal must be, it will be equal to minus 1 by m1. So therefore, since here normal and tangent are perpendicular to each other, if the slope of the tangent is dy by dx, obviously slope of the normal must be equal to minus 1 divided by dy by dx. Thus here f dash of x naught is nothing but the derivative of y with respect to x at the point x naught. Now, there exists some particular cases. So here a slope is nothing but dy by dx. Generally, we represent the slope with m, and also we know that dy by dx is nothing but tan theta. So we have learned the slope of the straight line can also be written in the form of y is equal to tan theta. So thus, whenever the slope of the tangent is 0, so that is whenever tan theta is clearly 0, then that is theta is equal to 0. If theta is equal to 0, that means what is the case if theta is equal to 0? Suppose here is a curve. If theta is equal to 0 means the tangent is exactly parallel to the x-axis. It is parallel to the x-axis because there is no inclination of the tangent with respect to x-axis. Hence, in that case, the equation of the tangent at that point will become y is equal to y naught. Also, you should know that theta is equal to 0 or tan theta is equal to 0 means it is nothing but dy by dx is equal to 0. That is, whenever the slope of the tangent, in the case of derivative, slope of the tangent is nothing but dy by dx. Thus, dy by dx becomes 0 means tan theta becomes 0. In that case, exactly tangent is parallel to the x-axis and hence its slope is 0 and equation is given by y is equal to y naught. Suppose if theta is equal to pi by 2, you take a curve. So this is x-axis and this is y-axis. You take any curve here. So if this is the tangent and it is exactly 90 degree, it is exactly 90 degree to the x-axis, then it means the tangent is perpendicular to the x-axis and parallel to the y-axis. So perpendicular to x-axis means it is parallel to y-axis. So in that case, the equation of the tangent at the given point is given by x is equal to x naught. So this is the line of equation x is equal to x naught. But what about the slope of the tangent? So here the slope of the tangent cannot be defined, but slope of the normal can be defined. So therefore here we can take slope of normal is equal to 0. See here, if this is the tangent, then this will be the normal. So normal is parallel to x-axis means we can take slope of the normal is equal to 0. That means we can take minus dx by dy. Or if you get any confusion, you can take it as minus 1 divided by dy by dx only, which is equal to 0. So thus, these are the two special cases. So whenever slope of the tangent is 0, that means tangent is parallel to x-axis and hence the equation becomes y is equal to y naught. And whenever the tangent is perpendicular to x-axis or parallel to y-axis, then the equation is x is equal to x naught. In that case, we can take slope of the normal as 0. So therefore here minus 1 divided by dy by dx, or we can take it in the form of minus dx by dy as 0. Because the slope of the tangent cannot be defined because it is infinity. So now let's solve the questions. Find the slope of the tangent to the curve y is equal to x cube minus x at x is equal to 2. So the slope of the tangent at particular point is also given. So here is given y is equal to x cube minus x. So let us derive it. Dy by dx is equal to derivative of x cube is 3x square. Derivative of x is 1. Now we need to find out dy by dx at x is equal to 2. So therefore we take dy by dx at x is equal to 2 is given by 3 into 2 square minus 1. So 2 square is 4, 4 3s are 12, 12 minus 1 is 11. So 11 is the slope of the tangent. Next, find the slope of the tangent to the curve y is equal to x minus 1 divided by x minus 2. X is not equal to 2 at x is equal to 10. Here the given function is y is equal to x minus 1, x minus 2. X is not equal to 2 here. Because whenever x is equal to 2, the denominator becomes 0 and it is not defined. So now this is in the quotient form. So let us apply the quotient rule here. So we get u by v whole dash is equal to u dash v minus v dash u divided by v square. So derive first, write second as it is. Next, derive second, write first as it is. So we get y is equal to derivative of x minus 1 is 1 and write x minus 2 as it is, minus derivative of second is 1 and x minus 1 is as it is, whole divided by x minus 2 whole square. Now y is equal to, so here it is x minus 2. Next here is minus x plus 1 divided by x minus 2 whole square. X minus x get cancelled. So this is dy by dx. Now here minus 2 plus 1 is minus 1 divided by denominator is x minus 2 whole square. Now we need to find out the derivative at x is equal to 10. So at x is equal to 10, dy by dx is equal to minus 1 divided by 10 minus 2 whole square, which is minus 1 by 64. So this is the slope of the tangent at the point x is equal to 10. Next, find the point at which the tangent to the curve y is equal to square root of 4x minus 3 minus 1 has its slope 2 by 3. So we need to find out the point of contact at which point the tangent meets the curve. So let us take here y is equal to root of 4x minus 3 minus 1. Now let us derive it. So we have dy by dx is equal to, so this complete equation must be taken in the form of root x. So if y is equal to root x, what is the derivative? It is 1 by 2 root x. So this is the derivative. So now therefore this can be written as 1 divided by 2 root of 4x minus 3. But 4x minus 3 is again one more function, so apply the chain rule. Now derive 4x minus 3. Derivative of 4x becomes 4 because derivative of x is 1. So 1 into 4. Minus 3 is completely 0 because it's a constant. Again here also derivative of minus 1 becomes 0. See, we are deriving this function, then it becomes minus 0 because 1 is constant. So we get here 2 1s are, 2 2s are. So therefore, dy by dx is equal to 2 divided by root of 4x minus 3. Now here we got the slope of the tangent as 2 divided by 4x minus 3. Here the slope is given, that is nothing but dy by dx is given. So it is 2 by 3 is equal to 2 divided by root of 4x minus 3. So 2 2 get cancelled, cross multiply, we get 4x minus 3 is equal to 3. Square on both sides, we get 4x minus 3 is equal to 9. We get 4x is equal to 12. So this implies x is equal to 3. So now we got x is equal to 3. Let us substitute for y. So here y is equal to root of 4x minus 3 minus 1. Y is equal to root of, what is the value of x? It is 3. 4 3s are 12. 12 minus 3, 9. 9 minus 1. Root of 9 is 3 minus 1. Therefore, y is equal to 2. So, therefore, here we need to find out the point. So, therefore, the required point is 3, 2. Therefore, the tangent meets the curve at the point 3, 2. So, here the slope is given, means dy by dx is given. From that, we can identify the point of intersection. Next, find the points on the curve x square divided by 4 plus y square by 25 is equal to 1 at which the tangents are parallel to x-axis. I already told you in the derivative, whenever tangent is parallel to, we have two cases. When it is parallel to x-axis, take dy by dx is equal to 0. B, when it is parallel to y-axis, take dx by dy is equal to 0. So take this as 0. That is, when it is parallel to x-axis, slope of tangent is 0. When it is parallel to y-axis, we can take slope of normal as 0. So this is nothing but slope of normal here. So what is slope of normal? Slope of normal is nothing but minus 1 divided by dy by dx. So when you take the reciprocal, you will get dx by dy. So you can take dx by dy as 0. So these are the conditions required to solve such kind of problems here. So now here also we need to find the point on the curve x square by 4 plus y square by 25. Clearly it is an equation of an ellipse and we have to find at which point it is parallel to the x-axis. So first let us write the equation x square by 4 plus y square by 25 is equal to 1. So both are in the same side. We can take it as an example of explicit function. Let us derive it. So we get derivative of x square is 2x and 1 by 4 is constant. Let me write it as it is. And again here derivative of y square is 2y and 25 is constant. So therefore I'll write as it is into dy by dx. Because when you are deriving y with respect to dx, we have to write dy by dx is equal to derivative of 1 is 0. Now here I'll get 2 1s are 2 2s are. So I get x by 2 plus 2 by 25y into dy by dx is equal to 0. Now since what is that given? Tangent is parallel to x-axis. Parallel to x-axis. This implies dy by dx is equal to 0. So substitute dy by dx is equal to 0 in 1. Let me take this as equation 1. So equation 1 implies, what does it implies? X by 2 plus 2 by 25 into 0 is equal to 0 because dy by dx is equal to 0 here. So here we get x by 2 is equal to 0. This implies x is equal to 0. Now we got x is equal to 0. Substitute x is equal to 0 here. So if you substitute x is equal to 0, now here we have x square by 4 plus y square by 25 is equal to 1. So if you put x is equal to 0 here, this implies y square by 25 is equal to 1. So y square is equal to 25. This implies y is equal to plus or minus 5. So therefore, the points of intersection are, one is 0, 5 and another is 0, minus 5. So hence here the tangents meet the curve at the point 0, 5 and 0, minus 5. Next is find the equation of all lines having slope 2 which are tangents to the curve y is equal to 1 over x minus 3, x is not equal to 3. So let us find the slope first. So we get dy by dx is equal to, so this can be written as minus 1 by x minus 3 whole square. Why? Because you can call it as generally, if y is equal to 1 by x, then dy by dx is minus 1 by x square. So therefore, in the place of x, you have x minus 3. So since this is in the form of 1 by x, we can write it as minus 1 by x square. And x minus 3, again when you derive it, it is nothing but 1. Now we got dy by dx is equal to minus 1 by x minus 3 whole square. So given that slope is 2 here. So that means dy by dx is equal to 2. So 2 is equal to minus 1 divided by x minus 3 whole square. So cross multiply, this implies x minus 3 whole square is equal to minus 1 by 2. See, x minus 3 whole square is a positive quantity, but here we are getting it as minus 1 by 2. Or when you take square root on both sides, we get square root of minus 1 by 2, which does not exist. So this kind of values does not exist. or you can write which is not possible, because this is exactly a positive quantity, but it is equal to minus half, which is not possible. So therefore, such tangents do not exist. So this means there are no tangents to the curve whose slope is equal to 2 for the given curve. Next question. Find the slope of the normal to the curve x is equal to a cos cube theta and y is equal to a sin cube theta at theta is equal to pi by 4. So here it is given in a parametric form. We need to find out the slope of the normal. To find the slope of the normal, we need both dy by dx. So therefore here what we will do, let us derive the parametric form first. So here we can write it as dx by d theta is equal to a cos cube theta is 3 cos square theta into minus sin theta. Apply the chain rule. Cos cube is given when first reduce the polynomial, then derive the function. So therefore, dx by d theta can be written as minus a sin theta minus 3a sin theta cos square theta. Similarly, y is given as a sin cube theta. So therefore here dy by d theta with respect to theta, a 3 sin square theta into cos theta. So therefore we get dy by d theta is equal to minus 3a sin square theta. Now here slope of normal. Which is nothing but minus 1 over dy by dx, correct? So this can be written as minus dx by dy. How we can get dx by dy? If you want dy by dx, you would have taken dy by d theta over dx by d theta. Similarly, dx by dy can be taken as minus dx by d theta divided by dy by d theta. So therefore, apply here. So this is equal to, what is dx by d theta? It is minus outside. So here I will take minus 3a sin theta cos square theta. And here we have 3a sin square theta cos theta. So 3a get cancelled. Sin theta cancels with 1 sin theta, cos theta cancels with 1 cos theta, and here minus into minus becomes plus. So therefore, slope of normal, now it is cos theta by sin theta. So what is cos theta sin theta? That is equal to cot theta. So we got the slope of the normal as cot theta, but the point is also given. We have to find out the slope of the normal at theta is equal to pi by 4. So therefore, at theta is equal to pi by 4, slope of normal is equal to cot pi by 4. So what is the value of cot pi by 4? It is 1. So therefore, the slope of the normal is 1. So thus in this session, we have learnt how derivative helps us to find out the slopes of tangent as well as slope of normal along with some particular cases also. We'll meet you in the next session with another important application of the derivative. Until then, keep watching, keep learning, keep exploring. Thank you.